Hello everyone, my name is Thomas Kim. Today is June 15th, 2019. This is my 32nd episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn Coroutine for the first time. In ISO CPP ORG website, Coroutine will be introduced to C++ 20 standard. In this episode, we will learn about Coroutine. As of today, there is not much resource about Coroutine. This is the best resource, C++ extensions for Coroutines. I highly recommend you read this technical specification. By reading this technical specification about Coroutine, you can learn most fundamental concept of how to use Coroutines. Also, I would like to recommend you this website, but this documentation is very short. It's hard to understand. Another very valuable documentation is from this website. I also recommend you read this documentation. Also, this is the best source. This is the best source about Coroutine. I highly recommend you read these documentations. By clicking this link, you can read more about Coroutines. I will put the link in the description section below. I will post complete source code to my website, extension talkplayfun.com website. By the time you watch this video, if you click this link and show in folder, unzip the folder, in the tutorials folder, you can find complete source code. After this video, I will post complete source code to my website. So you can download complete source code by clicking this link. Okay, let's get started. Start Visual Studio Code. In the tutorial folder, click this button, O32 Coroutine CPP, and I will create another file. Click tutorial once again, new O32 Coroutine HPP, hit enter, Ctrl V. So I created one CPP file and one header file. In HPP header file, include IO stream, include type trace, include experimental coroutine. In CPP file, include O32 coroutine HPP, int main, and I will create a function here. Before I create a function, in the header file, template, type name, semantic, return type, class, promise, type. So I declared a class named promise type, template, type name, semantic, return type, class, return, I say resumable type. So I declared two class, resumable type and promise type. So here, resumable type, template, type name, semantic, return type, semantic, return type, sum, semantic, return type A, semantic, return type B, co-return A plus B. So this is return type. It returns a class, resumable type class of semantic return type. This is our first coroutine. Co-return expression terminates the coroutine. Okay, like this. Auto cosum, sum 2, 3. Please note that this sum function, coroutine sum, returns this object. Okay, so I will copy like this for easier understanding. This is int because this is integral type. Okay, before we further proceed, I would like to share some tips with you. Suppose we purchased a new book and this book has 20 chapters. In my case, I usually read the preface, then I read the back cover. To understand chapter 1, you need to understand from chapter 2 through chapter 20. Again, to understand chapter 2, you need to understand from chapter 1 and chapter 3 through chapter 20. Don't ever try to understand chapter 1 completely. Also, never try to understand chapter 2 completely before you read all the chapters. My usual strategy is I read from chapter 1 to chapter 20 very fast. I don't get bogged down on a specific chapter. If I think the chapter seems difficult, I still read, but I read fast and skip a few sections. I try to read as much of the chapters, but I don't get bogged down on a specific section. Usually, at the first round of reading, read your book as quickly as fast. After reading from chapter 1 through chapter 20, then come back to chapter 1 again. Repeat this method to read the book several times. By the time you read the book 2 or 3 times, you can get the big picture of the book. Then you delve into more specific chapters and sections. This time, try to understand all the nitty-gritty details. My point is, don't get bogged down. Don't try to understand all at once. Repeat and think again. Always get the big picture, then the details becomes crystal clear. I bet Coroutine will be quite challenging for most of us, but still don't get bogged down. Keep reading and keep watching my videos. In future sessions, I will elaborate all the details one by one. Please note that resumable type and promise type works together. So we need to access resumable type from promise type, and also we need to access promise type from resumable type. So I need to declare forward. I forward declare resumable type here. This is forward declaration. Also, I will forward declaration here for promise type. And here also, I said we need to access resumable type from promise type. So, template, type name type, friend class, resumable type. Okay. Also in resumable type, template, type name type, friend class, promise type. So this is the first step. Now here in private section, No, step 1 here in public section, this is compulsory. Okay, in the resumable type public section, we have to define using promise type. We have to define this type alias like this, promise type, and promise type takes semantic value type. Okay, this is compulsory. How do I spell it? Compulsory. Okay, compulsory. This is must have. This type alias is must have. The C++ compiler needs to know promise type. Otherwise, coroutine does not work. This is very important. Okay, it declares this promise type declares to the C++ compiler that our promise type is promise type. Okay, this is very important. Now we define handle type like this using promise handle type. std experimental coroutine handle. We provide this promise type. Okay, this is not compulsory. This is not compulsory, but it is very handy for our use. Now in private section, we define promise type handle like this, m promise handle. Okay, this coroutine handle we define the promise handle type here, and this is a member in private section of resumable. This promise type we defined here. This member bridges between resumable type and promise type. Okay, this is the bridge between resumable type and promise type. So this is must have. And in the private section, we create constructor like this. We take promise type handle, we initialize it, handle. Okay, this is constructor. This is constructor in private section. Okay, so this is not publicly accessible. This is not publicly accessible. I hope you understand this concept. Now in public section, we create resumable type, constant resumable type. This is copy constructor. We disable copy constructor. Disable copy constructor. Resumable type is not copyable. This is very important. Now we create move constructor, resumable type, right hand side. This is move constructor. This m promise handle, we copy right hand side, m promise handle, we copied, then right hand side, m promise handle, null ptr. Okay, invalidate right hand side. So this is move constructor. Now here in the promise type public, we also define using resumable type, this is semantic type. Okay, this is for our own use. This is not compulsory, but for our own use. Now we also define handle type using promise handle type, SDD, experimental, coroutine handle. Here we provide this type like this. We defined, okay? The private section, please note that this is semantic type. Okay, this is semantic type. So when A plus B, the result will be saved in this variable. M semantic return value. Okay, the evaluation result of A and B will be stored here. The result of operation will be stored in this member variable. Okay, you understand this? Now here please note that this handle, promise handle, this handle is the bridge. I said this is promise handle type between resumable type and the promise type. This is the bridge. This is the bridge. So we can get like this. It is resumable type, semantic, return type, get. Okay? We can get like this. This promised handle, promise. This function returns promise, an instance of promise. Okay? At this point it returns, this object is returned. Okay? Then this object promise has this member. This promise type has this private member, semantic return value. Okay? So we can access like this. We can access, or I can say auto promise. I will make it clear. Then we can return promise and semantic return value. Okay, this promise is something like this. Promise type semantic return type. Okay, I will delete this. Then it has member semantic return value. So at this point, std cout sum 2 3 equals, so we call this get resumable type co sum get std and there. Okay, I hope you understand up to this point. So this is resumable type, this is resumable type co sum, and co sum we call this member function get. This get, using this handle, we retrieve promise. From this promise, it has member. It has this member. Okay, now here public. Now let's think about this. Auto get return object. Okay, what this return object is? In this function, this is coroutine. In the coroutine, the C++ compiler returns resumable type. Okay, C++ compiler returns resumable type. Please note that in this coroutine, CO return returns resumable type. So C++ compiler need to know this type. So we return like this. Return. This is resumable type we defined like this. Resumable type. And its element type is semantic return type. Okay. Now this type, resumable type, has a private constructor. This is private constructor. It takes promise handler type. Okay. So we have to pass here. A promise handler. Okay. A handler promise handler type like this. Promise handler. Okay. Then this promise handler, I will make it like this. I will make it bigger. I will copy it. I will make it bigger. SDD, experimental, coroutine handler, promise type. Okay. This handler type, this experimental coroutine handler type has a static member called prom handler, prom promise. Okay. It is a function. We have to provide this. This is this promise type. Okay. So from this syntax, we can, instead of this, we can copy like this. Copy from promise like this. Then this is a handler. Okay, this is a handler. Now we have to construct this resumable type. Okay, so this is the same. We are constructing a resumable type. I hope you understand this concept. So I will make it shorter. We are creating an instance. Also, this can be written like this. Okay, since we defined this type alias, we can copy like this. Then it's short and cleaner. Okay, I hope you understand what it means. I try to make short and clear. Now here we need a static void get return object on allocation failure. So this object resumable type is dynamically allocated. If dynamic allocation fails, get return object on allocation failure, then we return this type null ptr. Please note that this is a static member function. This is, sorry, it should be auto. This is static member function. Okay, this member function is compulsory. C++ compiler uses this function to create resumable type, semantic return type object for our coroutine. Okay, so C++ compiler use this function to create this resumable type. This function is also compulsory. This function is also compulsory. Okay, when dynamic allocation fails, then this function is used. I have to fix this part. I will talk more about this function and this function in my next episode or at the end of this episode. Okay, let's keep going. Void unhandled exception. We also have to define this function. I will also talk about this function in my next episode. std terminate. This is also compulsory. Okay, then here auto initial suspend return std experimental suspend always. This function is also compulsory. I will explain about this very shortly, so don't worry. Auto final suspend return std experimental suspend always. So this is a waitable object, suspend always. If we click go to definition, so this is suspend always. This is a struct. Okay, this function is also compulsory. This function is also compulsory. Auto return value semantic return type value. So this co return calls this function. Once again, co return passes the value, the expression a plus b, the result of a plus b, to this function. So this m, we save the value, store the value, store the result a plus b. This a plus b coming from co return to our member variable. Then we have to suspend return std experimental suspend always. Okay, so we suspend after storing the value, we suspend. So our coroutine suspends at this point. Now we are coming to resumable again here. Now here we need to define resume function. Bool resume. Please note that we are in resumable type. We are defining this type. If this mPromise handle is valid, this mPromise handle has a member function resume. Okay, we resume, then we return this mPromise done. Okay, so if it is not done, then we return like this. Else return false. Okay, we resume our suspended coroutine. If mPromise handle is invalid, then return false, otherwise resume coroutine and return true if not yet done. If done is true. Okay, anyway, we do this. Now here, let's see, I think we have done. We need to create this structure. Copy, paste, like this. If this promise handle is valid, please note that we can invalidate. When we move, we can invalidate promise handle. Okay, so we have to test. Then this promise handle destroy. Okay, we have to destroy the allocated memory. Everything seems to be done. In the promise, we say in the promise, initial suspended. Okay, we initially suspend. So at this point, our coroutine cosum is initially suspended. So we have to start, resume, cosum, resume. Okay, then we get the value. Now start command prompt, dir 032 cl ehsc std c++17 or latest. We have to give a weight. This switch is very important. Okay, then O32 coroutine cpp fe aexe, hit enter. Wow, it built without bug. CLS, wow, it's beautiful. Our first coroutine. Okay, now I will explain one more. I will add one more here. INTA, I say co yield, yield, A times B, co yield. Okay, now co yield, yield A plus B. Okay, then I will make another one. A minus B. Now I will copy this function once again. Copy, paste, paste. So this is the first time, this one, second time, this one, third time, this one. Now let's build once again. Sorry, I forgot one thing. In the promise type, this return value is for co-return. Okay, so co-yield, we need to define another one like this. Auto yield value semantic return type value. I will just copy this part, paste. I say this is for CO return value, and this is for CO co-yield value. Okay, I hope you understand this concept. To use this command, we have to define this function here. CLS, I will build once again. Don't forget this await switch. Hit enter. CLS. Wow. Say initially 2 times 3, 6. 2 plus 3, 5. This is a square minus b square. Okay, a square minus b square. 4 minus 9 minus 5. Okay, so this is some fundamentals. I guess this is quite challenging for you. Don't worry, I will explain all these details in my future sessions. In my next episode, I will explain how all these things work together. Before I close this episode, I can create one more function here. Let me see. Instead of doing this, resume, get, then I can say I will copy this and paste. Then I say next. I defined like this. Then first we resume this, resume, then return this get. I changed like this, and I say void test coroutine basic, and here anti-main. I will copy this function name, and here we can create more advanced coroutine. Template, type name, semantic, return type, resumable, type, semantic, return type, summation, int max. Here semantic, sorry, I have to copy this, return type s equals 0 for semantic, return type I equals to 1, I less than max, plus plus I, co yield s equals I. Okay, now let's see co return s void advanced coroutine. I will copy this function name and disable it. Auto cost sum summation 11. We are calling this coroutine for inti equals 0. I will start with 0 here. I less than 11 plus plus I. std cout summation. Next. Please note that we are calling this function next. Y is squiggle. Then let's build a. See, this function returns value, then it stops execution, then it calls again. Okay, so this is what is called coroutine. In my future sessions, I will explain more details and more examples until you completely understand the coroutine. Please subscribe to my YouTube channel. Thank you for watching.